we're going to talk about here in this next section is the right triangle trig. Now, most of you have been exposed to this a little bit in geometry and possibly in algebra. So this is the section that will probably be a review of that. There'll be a little extension on it. You'll see in the second slide here. But these are the three main trig ratios that you should be familiar with, right? Sine, cosine, and tangent. You guys should all be familiar with the saying. The acronym SOHCAHTOA is the one that helps you identify what these ratios are. And so if you look, and I'm just taking the first quadrant here on the unit circle. If we were to create an angle from the standard position here, theta, what we'll do and what we're going to be doing to identify certain trig ratios on the unit circle or on a circle here is we'll create a right triangle in that first quadrant. Our unit circle is going to have a radius of 1, so this hypotenuse is always going to be a 1 when I set this up. And so at this point, x, y, right here, what you can see is that x is this length of the adjacent leg. So this is adjacent here. Y is the length of this opposite leg. Again, this is the leg opposite the given angle. And then the hypotenuse is 1. And so when we're looking at the way that the SOHCAHTOA relationship is set up, what you should be able to see is, as far as the ratios go, is that the sine of an angle is equivalent to the ratio of the opposite leg to the hypotenuse. And that's where the S, the O, and the H are derived. The cosine is the ratio of the adjacent leg to the hypotenuse. Again, seeing where the C, the A, and the H come from. And then finally, the tangent is equivalent to the ratio of the opposite leg to the adjacent leg. Okay, so that's what the trig ratios are, the T, the O, the A. The trig ratios are just ratios between the two of the three parts of this right triangle formed at that particular, or with that given acute angle. Okay. So a couple things with regard to right triangle trig. First, if you're using right triangle trig, you're restricted to angles that are acute angles. It has to be between 0 and 90 degrees. In order to extend and go through angles that are beyond that, what you're going to need to do is use some properties that we'll talk about here in the next few sections. But you will use the rotational unit circle or circle trig to get beyond angles, or to get angles that go beyond the acute angles. Right? So if you look at the way this is set up, where your opposite side is a y, what you can see is that the sine of theta specifically, and so now I'm going to take these ratios and I'm going to apply it to this angle theta right here. What you see is that the sine of theta, and all the trig ratios that we're going to look at, so these three plus their reciprocal ratios, which we'll talk about in the next slide, they're all going to use three letters to indicate them. When you are stating these, the SIN is representing sine, and you'll pronounce it sine. It's not pronounced sin. This is just the sine of theta, and when you look at this ratio, it's the opposite, y over hypotenuse 1. So what you see right here is in this, on the unit circle right here, the sine of theta is just equivalent to its y coordinate on that circle. The cosine of theta is equivalent to the adjacent, which is x, over the hypotenuse, which is 1. So what you see is that the cosine is equivalent to the x coordinate. So really, this point right here, the coordinates of that point aren't just x and y, they're also the cosine of theta and the sine of theta. Okay, so when we get to where we're evaluating these, the trig ratios for the right triangle on the unit circle, the x coordinate and y coordinate are going to be your cosine and sine values respectively. And then finally, the tangent is opposite, which is y, over adjacent, which is x. And if you think in terms of what you see here, y is equivalent to which trig ratio? Sine. And x is equivalent to cosine. So this is something that will come up a little bit later, that the tangent is equivalent to the ratio of the sine over the cosine. But you can see that all here just looking at the right triangle trig. All right, so these are the ratios that you are expected to have covered already. Okay, I talked through them, but we'll do some more work with them. But hopefully you've gone through some trig ratios before. Okay, the three trig ratios that you maybe haven't talked about are what's called the reciprocal ratios: cosecant, secant, and cotangent. Okay, and these are the reciprocals of those main sine, cosine, and tangent. Okay, so if you look at the, again, sine, cosine, and tangent, okay, if you take each of these and you make them into reciprocals, meaning we divide, you just flip the fraction. So 1 over sine is the reciprocal of sine. What you're going to find is these remaining trig ratios. Okay, so the cosecant is the reciprocal of sine, and it's designated CSC. The secant is the reciprocal of cosine. It's designated SEC. And the cotangent is the reciprocal of tangent, and it's designated COT. Okay, so because of what we saw on the unit circle, since the sine is the y coordinate, we could think of this as 1 over y. The secant is the reciprocal of cosine. Since the cosine is the x coordinate, we can think of it as 1 over x. And the cotangent is the reciprocal of the tangent. So we can think of that again. Back here we saw that the tangent was y over x. So the reciprocal will be x over y or cosine over sine.